Welcome to Story-Driven, a context-synchronized storytelling system that creates a narrative experience tailored to a custom journey. The required user input only consists of the desired destination. The system then generates an audiobook that leverages user context and estimated arrival times to continuously adjust the story. This synchronization of the narrative with real-world locations blurs the line between fiction and reality, creating an immersive storytelling experience.
Under the watchful gaze of Pallas Athena, the goddess of wisdom, Elise Adler and Marcus Vogel approached the majestic Parliament building, its architecture a testament to a bygone era of enlightenment and grandeur.
The system dynamically selects points of interest along the route. To ensure an ideal selection process, a bounding box is calculated around the route. Based on OpenStreetMap data, relevant points of interest are selected. For these locations, an importance score is calculated, which is used to narrow down the list of locations. Finally, all possible combinations of points of interest with respect to the story structure are tested. The combination with the highest accumulated importance score is selected for the storytelling experience. The selected locations are used to generate a story. Additionally, contextual information about the weather, time of day, and season are fed into a large language model. The resulting story generation follows a systematic story plan, where the full story consists of 5 chapters following the narrative arc. The points of interest are divided among the 5 chapters. If a chapter contains more than one point of interest, subchapters are generated for each location. With the preparation process complete, the storytelling journey can begin. During the trip, the estimated time of arrival at the next point of interest is updated continuously. Simultaneously, the estimated time to mention of the location in the narrated story is approximated. To keep the story synchronized to the real world, the difference between the estimated time of arrival and the estimated time to mention is calculated periodically. As soon as the difference becomes too large, the story is edited accordingly. For example, if the estimated time to mention exceeds the estimated time of arrival, the remaining story content is replaced by a newly generated, shorter story. We evaluated the storytelling system in 2 real-world user studies, with 30 participants in total. The preliminary field test with 5 participants recorded a positive response towards the inclusion of contextual information from all participants. A follow-up comparative real-world user study was conducted with 25 participants. The study compared our context-synchronized storytelling experience against a generated baseline story. In a within-subject design, the participants experienced the context-aware and baseline conditions in a counterbalanced order. The results showed significant improvements of our context-synchronized storytelling system over the baseline in narrative engagement, geographic recollection, and user experience. Additionally, the qualitative feedback indicated that synchronizing the story with the real world creates a unique and engaging user experience. With future advances in machine learning, new ways to combine the real world and fictitious storytelling provide an exciting area to explore further.